Hello everyone, and today I wanted to show you all the very rough 3D printed prosthetic hand that I was able to design, code, and build. I've always been fascinated by prosthetics. The fact that we're able to take a piece of hardware and attach it to somebody's body is absolutely mind-blowing to me. And this was one of the biggest reasons why I chose to become a biomedical engineer. I've done a lot of research during my time here in college, but nothing has even come close to being a real prosthetic. So, here's my first attempt at creating my own prosthetic hand. I wanted to start off simple, some moving parts here and there, but overall not a prosthetic, just a simple 3D printed movable hand. However, the mechanics that allowed this hand to move are not ideal for controlling its movement, so I had to look for other options. That's when I discovered the Flexi Hand 2. I found the model on Thingiverse, and it was posted by an account called Gyrobot. I really liked the way the hand looked, and more importantly how it functioned, so I downloaded the model and got to 3D printing. I threaded some fishing line through each finger to allow the motor to pull the line to open and close the hand. The coolest part about this hand is that because I 3D printed the joints of the fingers in a flexible material called TPU, this allows the hand to spring back open after it is pulled closed. As you may be able to guess, we are going to need some kind of base to support the hand and house a motor. And as you can see here, I went through a few different bases before I found one I was satisfied with. When I was first thinking about how I'm going to retract the fishing line using a motor, I was really struggling. And I came up with this mechanism first, which is basically a spool controlled by some gears attached to the motor. When I tested this, it worked, but it was very inefficient, so I needed something else. This base was a much needed improvement. I got rid of the individual holes for each finger's fishing line and opted for a long oval hole all of the fishing line would go through. This greatly reduced friction and made the opening and closing of the hand much cleaner. I also changed the spool to be a little bit bigger, and the gear was a part of the 3D model instead of being a separate part. In this final base, I also changed the gear ratio from 1:1 to 1:2 to output a higher torque from the motor and reduce the footprint of the base. One small change that I made that made all of the difference was using helical gears in Fusion 360. These gears only fit together in one way, which ensures they do not slip while in motion. Now, I just needed a way to attach the hand to the base, and that's when I came up with these. These were some initial test prints I made. The one on the top is a replica of the base where I wanted the hand to attach, and the one on the bottom is a rectangle I planned to attach to the hand model if the attachment system worked. Once I made sure that the holes lined up, I added the rectangle to the hand model and attached it to the base. And now we are on to the star of the show. This is an EMG sensor that can interface with an Arduino to give real-time measurements of the electrical signals generated by a muscle. It only has 3 connections, a positive, a negative, and a signal. The signal connection is what will send the recorded data to the Arduino. Here you can see the electrodes that are used with this sensor. The sensor requires 3 of these to be attached to the arm to be able to read an electrical signal from the forearm muscle. Okay, so now we have a movable hand attached to a base, an Arduino, and a sensor. Now all we need is a way to control the hand. And this is where the stepper motor comes in. I ended up trying 3 different stepper motors before I came to this one. Some were not powerful enough to close the hand, while others were too big to fit in the base. This NEMA 17 stepper motor was perfect, as it would provide adequate torque to close the hand and would reasonably fit into the base. To control a stepper motor, we need something that can regulate the voltage and current set to the motor. Because the Arduino cannot do it on its own, we need a stepper driver. These are typically very easy to figure out, and all I had to do after deciding on the motor was Google what stepper driver was compatible with it and buy it. So, now all we need is some code to control all of these components, and we are ready to test the first prototype. This first part of the code is setting up the Arduino to control the stepper motor and begins the serial monitor for troubleshooting. This next part is setting up the sensor to send measurements to the Arduino and displays the data in the serial monitor for additional troubleshooting. So now we're at the part of the code that is actually controlling the motion of the hand. The if statement is telling the Arduino that if the incoming EMG measurement is higher than 300 millivolts, then activate the hand. A digital write will set the direction of the stepper motor, and the first for function is what will cause the motor to close the hand. The hand will then hold itself closed for half a second, and after the delay, another digital write sets the stepper motor to the opposite direction before the Arduino tells the motor to open the hand with another for function. Here we can see how the sensor attaches to the forearm muscle and how it connects to the Arduino. On the right you can see a buck converter and a power supply. I had to use these components as they were all I had on hand. I gutted the power supply from one of my 3D printers, however it was a 24 volt power supply, so I needed the buck converter to tune down the voltage to a 12 volts for this circuit. Now we can see the whole system working. As soon as I flex my forearm, the hand will close and open. After fine-tuning the EMG measurement required to close the hand, this was actually a very responsive system. And as you can see here, when I close my hand slowly or not flex my forearm as hard, the hand will not close. This project was a lot of fun, and I'm planning on refining this prototype in the future to be much cleaner. I want to have a better and smaller power supply that is 12 volts instead of 24 volts. I want to get the system out of the breadboard and into the base so the system is less dangerous. And I want to refine the connection between the hand and the base. So that's going to do it. Thank you guys so much for watching.